Hi everyone. Today we're going to study Pearson's product moment correlation coefficient. Let us define correlation. Correlation is a statistical method used to determine whether there is a relationship between variables. The correlation coefficient always lies between -1 and +1. A correlation coefficient of -1 occurs when there is a perfect negative relationship between x and y, while a correlation coefficient of +1 occurs when there is a perfect positive linear correlation between x and y. A correlation coefficient close to -1 or +1 implies that there is a strong negative or strong positive relationship between the variables. Finally, a value of 0 indicates no relationship between the two variables x and y. Let us define scatter plots. Scatter plots is a graph of ordered pairs xy of numbers consist of the independent variable x and the dependent variable y. The plot indicates the direction of the relationship, whether positive or negative or no clear relationship. Here are the scatter plots for a positive correlation, negative correlation, and no correlation. Take note that in a positive correlation, the points seems to follow a line that leans on the right. On the negative correlation, it seems that the points follows a line that leans to the left. And in no correlation, all the points are scattered, so we can say that they follow a line that is horizontal. Let us study now the Pearson's product moment correlation coefficient. One of the measures of the degree of linear correlation between two variables is called the Pearson's product moment correlation coefficient, or the correlation coefficient, denoted by small r. This is the formula. R equals, the numerator is n times the summation of xy minus the product of summation of x and summation of y, all over this square root of the quantity n times the summation of x squared minus the square of summation of x multiplied by the square root of this quantity, which is n times the summation of y squared minus the square of the summation of y. The value of n is the number of pairs. Let us see this example. Calculate the Pearson product moment correlation coefficient. Given is the table below. The first column is the variable x representing the number of odds. The second column represents the variable y, which is the sales. Given this data, the first thing that we will do is to get the total of each column. The total of X, we write summation of X equals 45. And the summation of Y equals 38. To continue, we need 3 additional columns. The first column is XY, second is X squared, and the third additional column is Y squared. In the column XY, we are going to multiply the values of X and Y respectively. So we have here 2 times 2 is 4, 5 times 4 is 20, 8 times 7 is 56, 8 times 6 is 48, 10 times 9 is 90, 12 times 10 is 120. Then let us get the total of this column, and we name it summation of XY equals 338. The second column is the X squared. It means all values of X must be squared, and we will place in this column. So we have 2 square is 4, 5 square is 25, 8 square is 64, another 8 square is 64, 10 square is 100, 12 square is 144. The summation of this column is summation of X squared, and this is equal to 401. The last additional column is for Y squared, and that is, we're going to square each value of the Y column. So we have 2 square is 4, 4 square is 16, 7 square is 49, 6 square is 36, 9 square is 81, 10 square is 100. And the summation of Y square equals 286. All the summations down here are needed in our formula for the Pearson product moment correlation coefficient. Let us substitute the corresponding values. The n here is the number of pairs, so we write 6 times 338 minus 45 times 38 all over the square root of the quantity 6 times 401 minus the square of 45, and this will be multiplied to the square root of the quantity 6 times 286 minus the square of 38. Simplifying further, we have the numerator becomes 2028 minus 1710. In the denominator, the big radicals become square root of 381 times square root of 272. Simplifying further, we have 318 in the numerator over the denominator, that is 321.91924, and the quotient is 0.988. We can see that the value of R is close to positive 1. So we interpret this as there is a strong and positive correlation between these two variables, which are the number of odds and the sales. This is the final answer. I hope you learned something from this video. See you again next time.